In this video, we're going to solve the October-November 2019 session paper 1, and let's get started right away. So here we have question number 1, part A, in which we have to evaluate, and we can see that we have two fractions and we have to subtract them. So the first fraction is in mixed number form, so the first thing that I will have to do is I'll have to convert this into an improper fraction. So 8 ones are 8, 8 plus 1 is 9, so we have 9 over 8 minus 1 over 4. So I can't subtract them right away, that means I'll have to take out the LCM. So let's take out the LCM. The LCM of 8 and 4 is going to be 8. So I'll leave the numerator of this the first fraction as it is, so that's going to be 9. And then for the second fraction, I'll have to multiply 4 by 2, so that means I'll have to multiply 1 by 2 as well. So 9 minus 2 is 7, and then we'll have 7 over 8 as our final answer. You can give this in decimal form also, it will still be accepted. Now we have part B, in which we have to evaluate 5 over 9 divided by 2 upon 3. So we don't divide fractions, what we do is we change them into multiplication and we take the reciprocal. So the reciprocal of 2 upon 3 is going to be 3 upon 2. Now before we multiply, let's simplify them. So 3 ones are 3, 3 threes are 9, and then we have 5 upon 3 times 2, which is 6. So 5 upon 6 is our final answer. Again, if you wish to get this answer in decimal form, you can totally do that. It will still be accepted. Okay, next we have to write these values in order, starting with the smallest. So basically we have to write them in ascending order. So in order to be able to compare them comfortably, we need to make sure that all of them are in the same form. Right now one is in fraction, one is in percentage, and the other is in decimal. So what I'll do is I'll instead write all of them in decimal. So we're going to start by 7 upon 200. So let's figure out what 7 divided by 200 is. So we start by putting a decimal so that we can add a 0. So still 70 is smaller than 200. That means I'll have to add a 0, so I can add another 0. So now 200 times 3 is going to give us 600, and we'll have 100 left over. And then I can always add 1 0 after I have the remainder. So 200 multiplied by 5 is going to give me 1000, and then we'll have 0. So that means 7 over 200 is basically equal to 0.035. Now 4% basically means 4 upon 100, and 4 upon 100 is going to be equal to 0.04. 3 upon 50, let's work out what 3 divided by 50 is. So we're going to put a decimal and then a 0. So again, 30 is more than 50, so I'll have to put another 0, so I can add another 0. And then 50 times 6 is 300. So now we have 0 left over, so that means this is equal to 0.06. And then we have 0.03, and then let's work out what is 1 upon 20. So 1 divided by 20, we start by putting a point, 0. Same procedure, put a 0 so that we can add another, and then 5. So we have 100, 0, and this is equal to 0.05. Okay, now the best thing to do is to make sure that all of them have equal number of decimal places. So for that, what I'll do is, we can see that the most number of decimal places are 3, and that's for 0.035. So I'm going to write them like this. I'm going to let the first one be as it is. Okay, so and then in fact let's just add a 0 towards the end. So here we have another 0, 0, 0, 0. So now all of them are 3 decimal places. So we're going to look for the smallest. So the smallest I can see here is 0.030. So this right here is the smallest, so I'll just put a 1 here. So 0.030, and then greater than 0.030 will be 0.035. But remember, when you're writing 0.035, you have to write it in the original form that was given to you, and for that reason I'm going to have to remove the 0 that I put here. So and then we're going to have 7 upon 200 at number 2, and then at number 3 we have 0.04, 0.06, 0.05. So 0.04 is going to be at number 3, that means 4%. And then at number 4 we're going to have 0.05, so that's going to be 1 upon 20. And then finally at number 5 we have 3 upon 50, which is the largest in value. Okay, now let's do question number 3. From this list we have to write down a prime number, a square number, and an irrational number. Okay, so a prime number is a number that has only 2 factors. One of them is 1 and the other the number itself. So the only prime number that I can see here is 37. And then a square number means a perfect square, so 36 is the only perfect square here. An irrational number, so an irrational number is a number that cannot be expressed as a fraction of 2 integers. So it can't be square root of 36 because that's equal to 6, so it has to be square root of 35. Okay, Now I move to question number 4, where we have to solve this equation. Again, this is very easy. Gather all the x's on one side and then all the constants on the other. So we're going to have 7 minus 6, 10x equals to 1, x equals to 1 upon 10 or 0 0.1, whatever you wish to write it as. I'll write it as 1 upon 10. Okay, now question number 5. We have two values and both of them are perfect squares, and we have a minus sign in between. So whenever that happens to be the case, we rewrite them as their squares. So 49 can be written as 7 square and 90 square can be written as 3t whole square. So this is similar to a square minus b square, which can be factorized and written as a plus b into a minus b. But instead of a, we have 7, and instead of b, we have 3t. So we're going to have 7 plus 3t and then 7 minus 3t. So let's write that in the space provided. 7 plus 3t, 7 minus 3t. Okay, and whenever you have 4 terms, it's best to take common. So I can take 5 along with x common. It's best to make pairs and take common. So if I take 5x common, so I'm going to have 3y plus 1. And then in the next, I will factor out minus 2. The reason why I'm factoring out minus 2 is so that the sign inside the expression, inside the bracket are the same. So 3y plus 1. So we have 5x minus 2 into 3y plus 1 as our final answer. Okay, now question number 6, which says a movie lasts for 1 hour 48 minutes and finishes at 10:15 p.m. Find the time it starts. Okay, so what I'll have to do is I'll have to take 10:15 p.m. and from it I'll have to subtract 1 hour and 48 minutes. So I'm going to have to subtract 1 hour and 48 minutes. So I can't subtract 15 from 48. So what I'll do is I'll give 60 minutes. I'll basically reduce 10 by 1, and I will give an hour in the shape of 60 minutes to 15. So that's going to become 75. Now I can conveniently subtract. Let's write this as 09, 1 hour and 48 minutes from the time above. So 75 minus 48, let's figure that out. We reduce this by 1, so we carry the 1. 15 minus 8 is 7, 6 minus 4 is 2, and 9 minus 1 is 8. But remember, this is going to be 8:27 p.m. Okay. Now we have part B, which says the size of a television screen is given as 95 centimeter, correct to the nearest 5 centimeter. Write down the upper bound of the size of the television screen. Okay, so you have 95 centimeter here, which is correct to the nearest 5 centimeter. So the way to calculate upper bound or lower bound is that what we do is we look at what it's rounded off to. So we can see that this is rounded off to the nearest 5 centimeters. So we split 5 two ways and we get 2.5. Now for the upper bound, I'm going to add 2.5, which is going to give me 97.5. And if the question had asked for lower bound, we would have subtracted 2.5, and that would have given us 92.5. So 97.5 centimeter is our upper bound. Okay, now let's do question number 7, part A. 7 part A is similar to a question that came in 2018 summer session, and here we have to draw the line of symmetry. And so let's see. If you want the circle to be symmetrical, the line of symmetry has to pass through the center, of course, and it has to pass in such a way that the two chords that are already drawn become symmetrical. So this is the only logical line of symmetry that we can have, and we can see that if this circle was cut through along this line, we would get two identical halves, or you can say that one half would be the reflection of the other. Okay, now we have in the diagram below two small triangles are shaded. Shade one small triangle to give a diagram that has rotational symmetry of order 3. Now at this point I should mention that I have a video on rotational symmetry, which I would strongly suggest that you guys watch it to understand what rotational symmetry basically is. Now how are you going to solve such a question? Let's find out. So basically the best way to solve a question like this is to start numbering your triangles. So I'm going to start from the base, and I'm going to start from the right hand side. So 1, 2, 3, 4, 5, 6, 7. So we can see that it is the fifth triangle of the base that is shaded. Now what will happen if I rotate this base? We know that this line, once rotated, is going to end up here. Okay, and the triangle that's shaded should be the fifth triangle if we start counting from the bottom left. Okay, so let's start counting. 1, 2, 3, 4, 5, 6, 7. We can see again that it's the fifth triangle that is shaded. So now what will happen if this line is rotated? It is going to end up here, and again, in order to make sure that this figure has a rotational symmetry of order 3, we're going to shade the fifth triangle. So again, let's start counting carefully. 1, 2, 3, 4, 5. So this is the triangle that needs to be shaded in order to make sure that this figure has a rotational symmetry of order 3. Now again, I would strongly urge that you watch the video on rotational symmetry in order to better understand the concept of rotational symmetry, and which will definitely help you solve questions like these. Okay, so now we have question number 8, which says by writing each number correct to one significant figure, estimate the value. Okay, so if I were you at this point, I'd underline one significant figure. So 39.864 can be either written as 39 or can be written as, can either be written as 30 or 40. But since it's closer to 40, I'm going to round this off at 40. 8.987 can either be rounded off to 8 or 9, but since it's closer to 9, so I'm going to round it off to 9. And then 0.6, however, can either be written as 0.6 or 0.7, but since we have a 0 right after 6, so I'm going to have to leave this at 0.6 only. So this is going to become 40 times 3 over 0.6. 40 times 3 is 120. 120 divided by 0.6. Let's see. Let's turn 0.6 into integer by multiplying both the numerator and the denominator by 10. So we have 1200 upon 6, which can be written as 200. 1200 upon 6 is basically 200. 6 ones are 6, 6 twos are 12, 6 zeros are 0, and 6 zeros are 0 again. So we have 200 as our answer. Okay, now let's do question number 9. Let's see what question number 9 says. It says a map has a scale of 5 centimeter to 2 kilometer. The actual distance between two masts is 14 kilometer. Calculate the distance in centimeter on the map between the two masts. Okay, so 5 centimeter to 2 kilometers. So we're going to write 14 kilometers under kilometers and x under 5. Let's cross multiply. So 2x is equals to 5 times 14. Let's simplify. 2 ones are 2, 2 sevens are 14. So x is equals to 5 into 7, which is 35. So we have 35 centimeter as our final answer. Okay, now we have part B, which says on the map the surface area of lake is 50 centimeters square. So find the surface area in kilometers square of the actual lake. Okay, so we're going to have 5 centimeter is to 2 kilometer here, and then since the scale that's given is only suitable to convert length, so if you want to use the scale for area, or if you want to apply the scale to area, what you will have to do is you'll have to square both sides, so that you can change the unit from centimeter to centimeter square and from kilometer to kilometer square. So we have 25 centimeters square, since the square of 5 is 25, is basically equal to 4 kilometers square. Now you can safely use this scale for area, and a lot of students forget to do this step, which is why they get their answers wrong. So I'm going to write 50 under 25 and x under 4. Let's cross multiply, so we can see that 25x is equals to 50 times 4. 25 ones are 25, 25 twos are 50, so x is equals to 8 kilometers square. Okay, now we have write the scale 5 centimeter to 2 kilometer in the form of 1:n. Okay, so usually a ratio question will have something similar to this. So what we'll do here is we'll make sure that the units are the same. So when I'm making the units the same, I'll make sure that I will convert the larger unit into the smaller unit so that I don't have to deal with any decimals. So I'll let 5 centimeter be as it is, and I'll change 2 kilometers to centimeters. So if I want to change 2 kilometers to meters, I'll multiply it by 1000, and then if I want to change that to centimeters, I'll multiply it by 100. So we both the values are now in centimeters. That means we can ignore the units and simplify this. So 5 ones are 5, 5 fours are 20. Yeah, 5 fours are 20, and then we're going to have 1, 2, 3, 4, 4 zeros. 1, 2, 3, 4. So 1 is to 40,000 is going to be your answer. Okay, now the question says y is inversely proportional to x when x equals to 2, y is equals to t. Find an expression for y in terms of t when x equals to 3. Okay, so at this point I should mention that there are two ways to solve this question. One is the conventional way, which a lot of students are mostly used to, and what is that? That is that y is equals to k upon x, and then we find the value, k upon x, yeah, and then we find the value or expression for k. In this case, we can only find an expression because the value of y is not given. So y is t, so k as it is when x is 2, so k is equals to 2t. And then we're going to have y is equals to 2t upon x. And then what we do is we plug in the value of x which is given to us and find what y is equals to. So y is going to be equal to 2t upon 3. So this is one method. The other method that you can use, which is a lot easier, is that you write y here, you write x here, and then you write I dot p, which is short for inversely proportional, so that you know that you have to multiply head to head. So the question says that x equals to 2 when y equals to t. Find y in terms of t when x is 3. Okay, so we have to find y when x is 3. So I'm going to multiply head to head. So 2t is equals to 3y and y is equals to 2t upon 3. So both of them are going to give you the same exact same answer. It's just that I find the second method a lot easier. But then again, it's entirely up to you, whatever method you want to use. Okay, so now we have expressed 4500 times 1000 square in standard form. Okay, so first of all we need to first of all let's fix this 4500. So if I want to fix this 4500, in fact let's fix 1000 first. So let 4500 be as it is, and 1000 can be written as 10 cube, the whole thing squared. Okay, so I've just changed 1000 into 10 cube. The square is just as it is carried forward. So 4500 into 10 raised to the power 6. So now let's fix 4500, and for that I'll have to move the decimal 1, 2, 3 places backwards, and multiply. Moving the decimal 3 places backwards means adding 3 to the power. So I'm going to have 4.5 multiplied by 10 raised to the power of 6 plus 3, which is 9. Okay. Now 2.4 divided by 4 multiplied by 10 raised to the power minus 8 over 4 into 2.4 multiplied by 10 raised to the power minus 8 divided by 4 multiplied by 10 raised to the power minus 3. Okay, so what I normally tell my students at this point is that, remember, you got to compare apples with apples and oranges with oranges. Now 2.4 and 4 are referred here as the apples, and 10 power minus 8 and 10 power minus 3 are referred here, or I'm referring 2 power minus 8 and 10 power minus 8 and 10 power minus 3 as oranges. So I'm going to find out what 2.4 divided by 4 is, and in the meantime let's simplify 10 power minus 8 over 10 power minus 3. Same bases are being divided, that means we'll subtract the powers. So the powers we can take care of very easily. Minus 8 plus 3 is going to become minus 5. Now let's figure out what 2.4 divided by 4 is. So I'm going to multiply this by 10 and this by 10. So I'm going to have 24 upon 40. I'm going to simplify this with 4. So that's going to give me 4 6 are 24 and 4 10s are 40. Now I'm going to take advantage of 6 upon 10 and not simplify it any further, because 6 upon 10 I know can be written as 0.6. But this at this point is not in standard form, and in order to bring this in standard form I'll have to move the decimal one place forward, and whenever the decimal is brought one place forward we deduct 1 from the power. So this is going to become 6 multiplied by 10 raised to the power minus 6. So that's our final answer. Okay, now let's do question number 12, which says a polygon has 12 sides. Calculate the sum of interior angles of this polygon. So in order to calculate the sum, the formula used is n minus 2 multiplied by 180. So n is 12, so 12 minus 2 multiplied by 180. So that's going to be 10 multiplied by 180, which is going to be equal to 1800. So our answer is 1800. Okay. Alright, let's do question number 13. So we have 2x squared, the whole thing raised to the power of 0. Let's see, what is that? So 2x squared, the whole thing raised to the power 0 is going to be equal to 1. Actually, anything raised to the power 0 is 1. 3x cubed whole thing squared means that we're going to square 3, and we're also going to square x cubed. So the square of 3 is 9 and the square of x cubed is power 6. Okay, now we have 8 upon x cubed raised to the power of minus 1 upon 3. So the first thing that we'll have to do is we'll have to make the power positive, for which we'll have to take the reciprocal. So x cubed upon 8, and now the power is going to be positive. So now let's take the cube root. So cube root of x cubed upon 8. Cube root of x cubed is going to be equal to x, and the cube root of 2 is going to be 2. So we have x upon 2 as our final answer. So at this point we're done with half the paper, and that's all for this part. In the next video we will solve the remaining part, and I'll see you guys in the next video. Until then, take care. Bye bye.